Hello everyone. Today I'm going to show you how to use Excel solver to solve system of equations. And this is the spreadsheet that you're going to working on. And here are each tab. So today we're going to solve 5 problems. This first one is a single equation, also system of linear and nonlinear equations, also a heat balance problem, and an optimization problem. So before we start the problem, we have to install the Excel solver first. So if you go to the Data tab, so here is supposed to have a solver, which I don't have right now. So I would have to bring in and install the Excel solver first. So you can go to Files and go to Options and do add-ins and click that and say, so the manage, so you have Excel add-ins and click go, and we have solver add-in, so check the option solver add-in and say OK. And after this, as you can see under Analyze, so there is a solver here, and you probably need to restart Excel before you can use it, and we'll see. If it's not working, then we would have to restart Excel solver. Anyway, so let's get started. So you can go to the first tab first and type in the equation that we're going to work on. So I'm going to have you type in equations so you're comfortable with typing in formulas. So you can go to Insert here and go to Equation and type in the equation. So the equation that we're going to work on is going to be x cubed. So you can go to the script one and insert this one first and do x cubed and minus 10 times a bracket, and in the bracket is going to be x minus 1, and it's going to square. So I'm going to move the mouse here and insert another superscript, and drag this, so select this part and right click of the mouse and cut, and right click and do copy. I'm sorry, it should be paste. So go back here, do a Control Z, so you can go back and cut and go here and paste. So paste like this and square it and move the direction and equal to 1. So this is probably too small, so I'm going to select the box and change it to maybe 16 of the font so we can see it better. And right now it's on all cells. I want it to be white as the background, so I'm going to select this box and do the color here, and I'm going to select the first one, which is a white color instead of no fill. So I'm going to do white color here, so it's on all the cells instead of be transparent. And now I'm going to save the work, and I'm going to move to the second tab. So I'm going to tap all equations first. So the second one is going to be a system of linear equations. So I'm going to have a whole bunch of linear equations there. So I'm going to do insert again. So insert equation. And the equation right now, like we said, it's a equations system. So I'm going to go to the bracket one more time and scroll down. And I'm going to have 3 equations. So I'm going to select the brackets here. So the first equation that I'm going to have is going to be x plus y plus z equals to 6. And the second one is 2y plus 5z equals to minus 4. And the third one is 2x plus 5y minus z equals to 27. So this is too small, and I'm going to make it as font 16 as well, and make the background as white. So I'm going to move it to the right. So click the function and do space key. So I'm trying to make a y, it's lined up, and z, it's lined up as well. And so x, y, and z, yeah, it's better. So equations like this is called linear equations. So linear equations means you have x, y, z only. You don't have any square, any cube on it, and you could have a constant in front. So no cube, no squares, and also no exponentials, no log, no log, so has variables only, and power to 1. So this type of equations system is called a linear equations. So system of linear equations, or called a simultaneous equations. And this is the second one, so I'm going to save the work. And the third one, so I'm going to the third tab and type in the third equation. So it's going to be a system of nonlinear equations. So nonlinear equations. So I'm going to go to insert again and insert equations. And this time there are going to be two equations. So I'm going to do the two conditions here. And the first equation is going to be 2 times x squared. So I go here and do x squared and plus y squared. Do it one more time. So y squared and equals to 1. This is my first formula. So I'm going to make it bigger first so you can see it better. So the color is white background. The font is 16. And I'm going to put it here. And the second equation is going to be, so first of all, I'm going to make it as the superscript, and I'm going to put insert the parenthesis, and it's going to be 0.5x minus 0.5, and the square, then square, then move to the right, and plus 2 times similar format. So I'm going to copy this whole part. So Control C is copy and Control V is paste. So I'm going to paste with the source formatting and something like this. So instead of this part, it's going to be just a Y, and the number is 0.25. and the square as well, and move to the right equals to 1. So this is my second formula. And save the work. And maybe I'll put it to here. And let's go to the next tab. It's going to be a heat balance problem. So I'm thinking about this is a cylindrical pipe. So if there is a hot fluid in, I probably want to insulate the pipe so the temperature of the fluid does not go down very fast. So I want to add insulations on the outside of the pipe. And what's the thickness of the insulation? I should bring it in order to not get the temperature of the inside of the fluid drop too low. So that's the thing that I need to figure out. In order to figure out that, I would have to solve the heat balance equation, which is a heat transfer problem. So I'm going to type in the equation there as well. So I'm going to insert again and go to equation and make it bigger as 16, and the background color is white. And I go to click here and go to tap the equation, and here, so I have a design here. So I'm going to type in A first, and I'm going to add a fraction. The first one is a good one, and I'm going to do the superscript. Oh, I'm sorry, it's supposed to be subscript, so I'm going to go back, undo it, and subscript the second one, and it's TF minus, I need another subscript, so TI, and the bottom is same one, it's subscript, and it's RP, R sub P plus R sub I, and equal H. I could leave a space in between so you don't get confused. This should be a capital A, and leave another space, and do a parenthesis, and inside one, so it's similar with this. So I'm going to copy this part and go here and Control V and paste it and change the format. And instead of a F, it's going to be an I, and here it's supposed to be a A. So this is the second part, and a plus, which is going to be a radiation part. So I'm going to have a sigma first. So I could go to design here, and right here you have all Greek letters. And if you don't, so you could change it to Greek letters. But as the basic math, I do have a sigma there. So I can select a sigma, which is this letter, and leave a space, and do A, and put the symbol epsilon. So this is what I want. Then I'm going to go to a bracket again and insert brackets, and I would need so go inside, and I will need parentheses as well. And for the parentheses, I'm going to have a subscript, and it's going to be TI and plus 460, and I would need to power to 4. So I'm going to here and insert the first one, and cut the first part and copy it to there, and power to 4, then move the mouse, and minus, and the second part is going to be similar. So I'm going to just copy this part and paste it to the second part, and instead of a TI, it's going to be TA, and this is the equation that I have. So in heat transfer, I'm going to leave a space. So in heat transfer, it's going to be the first part is going to be the conduction of heat transfer, and the second part is the convection of heat transfer, and the third part is the radiation of heat transfer. So basically the fluid inside, so it's going out, first of all, it goes the conduction through the pipe wall and the insulation, and after it's going out of the insulation, the heat transfer is going to be convection heat transfer and also radiation heat transfer. So this is the heat balance. And also the temperatures, so TF is the temperature of the inside the fluid, and the temperature TI is going to be the temperature of the insulation, so which is the surrounding, so it's the inside of the pipe, and also I put the insulation outer, so that's the temperature of the insulation, and the TA is the temperature of the surrounding air's temperature, and R values, they're the insulation R of the material, so this is the pipe, this is the inside this is a pipe and this is the insulation. So both of them, they have R values. And as you can see, insulation's R value is a lot of bigger than the R value of the pipe. That's why it's called insulation. And anyway, this is the equation that we need. I'm going to leave it here and move to the last tab. The last tab is going to be an optimization problem. So it's a department store staffing problem. So the store operates 7 days a week and need a minimum number of salespersons. So we need 12 people on Monday at least, and 18 people at least on Tuesdays, and 20 on Wednesday, 28 on Thursday, 32 on Friday, 40 people on Saturday and Sunday, and each salesperson needs to work 5 days a week with 2 consecutive days off. And is asking what's the minimum number of salespersons do we need in order to minimize the number of people. So the solution is going to be we make x sub I as the number of salespeople that start their week on day I, such as the people, if they start on Monday, so they're going to work Monday, Tuesday, Wednesday, Thursday, Friday, and have their Saturday and Sunday off. And if they start work on Tuesday, so they're going to work on Tuesday, Wednesday, Thursday, Friday, Saturday, and have their Sunday and Monday off. And this is what they mean by the 2 consecutive days off. And our objective function is going to be minimize the number of staff, which is the number of staff starting on Monday, starting on Tuesday, starting on Wednesday. So we want to minimize the total number. And subject to, so we have some constraints. So on Monday, we have to have at least 12 people on the shift, and Tuesday, 18 people on the shift, and until Sunday, 40 people on the shift. And when people start work on Monday, so they're going to work on Monday as well. And when people start work on Tuesday, so they're going to have their Sunday and Monday off, so they're not going to work on Monday. So we skip that. And the same thing when people start working on Wednesday, and they're going to work on Thursday, Friday, Saturday, Sunday, and have their Monday and Tuesday off. So they're not going to work on Monday here either. And so when people start work on Thursday, then they get their Tuesday and Wednesday off. So they do work on Monday. So we have people Thursdays and Fridays, Saturdays, and Sunday, and sum them together. So we need to at least have 12 people on the shift on Monday, and the rest of them, they are similar, so you can take a look at on your own. So this is the function that we're going to work on. Now we have all the equations tapped in, so we're going to use Excel solver to solve all this problem. And the first one, so go to the first tab, it's a single equation. So in order to solve the equation, we're going to move everything on the left. So it's this first part, second part, and -1 because we're moving everything on the left part. Leave 0 on the right side. So here we're going to tap in the formula first. So you put equal sign here and tap all the equations here. So everything X, so you click this cell. This is your X. So X and cube. So you do a shift and do a 6. Okay, so which is the power 2 key. So once again, you hold the shift and tap the number 6 on your keyboard. That's the power 2. And tap 3 there. And -10 times and put a parenthesis there. And it's x minus 1, so whenever you see the variable, it's you cite the cell here, and the minus 1, and close the parenthesis and square it. Once again, it's a shift 6, and square it, and the minus 1. Like we said, you move everything on the left, and this is your formula. And after you're done, you hit enter, and this is your formula. So as you can see, x is 0 right now, so the value is minus 11. And if I put 1 here, then my formula is 0, and actually, which means 1 is one of the solutions here. And this is x cubed, and from your math class, you all know there are going to be 3 solutions for this formula because it's x cubed. So 3 solutions for this equation. And if I change to 2, as you can see, the formula changed, and whatever number I put there, the value is going to be different, and we're looking for the values that satisfy this formula. So like we said, there are going to be 3 answers, and depending on your initial guess. So this is a nonlinear problem because, like we said, it has a cube there, so it's nonlinear equation. So the solution will be depending on your initial guess. So let's put a 0 here as my initial guess, and go to Excel solver, see what solution I can get. So I go to data first. Once again, your solver may not give you a solution because we just installed, then you would have to restart. Let's see what's going to happen here. So I go to the data tab and go to solver here. So my objective function is going to be the formula I just tapped in. So I move my mouse here and select the cell I just tapped in. And this is my objective function, and I want my objective function to be 0. And remember, we moved everything to the left, so the right side is going to be 0. And by changing variables, and x is my variable, so I'm going to select this cell here. This is my variable, and we don't have any constraints so far. In the next problem, we're going to use it. And also with select, it's nonlinear problem here. So we do a nonlinear problem here. And now we click solve, see if we get the solution. Oh, we got some formula is incorrect. So let's take a look at the formula, see what's wrong with that. So I'm going to close that. The cell is a single cell on OK. Then, oh, I clicked the wrong one. Close it. Oh, Excel got a problem. Close it. Okay, objective cell must be on single one. So I'm going to delete it. It's probably that kind of thing. Anyway, so I'm going to select it one more time. Oh, this looks right now. So this is objective 1. And do solve. And find a solution and say OK. Okay, it works. And let me save the work one more time. So it means, so this number means 4 times 2, or 4.2 times 10 to power 2 negative 6. So this is, we treat Excel, we can treat it as 0 because this number is super small. So the number of that is 0.0060, so there are 42. Let me see, 1, 2, 3, 4, 5, 6. Yes, I'm right. So it's this number, super tiny. So we treat this as a 0. It means the formula is 0, and when x equals to this number here. Okay, so this is the one that Excel solver found the solution. So I'm going to copy this number. So copy, Control C, and paste it here. So this is one of my solution. And I'm going to take out the color here and move that, make it as no fill. and save the work. So this is my one solution, and like we said, it's going to be 3 solutions here depending on my initial guess. So right now I'm going to change my initial guess. It was 0, and I'm going to make it as 10 and see what's going to happen. So if my initial guess is 10, my answer is going to be 189. So let me run solver one more time. So go to the data tab and go to solver here, run it one more time. So objective function, the cells, it remains the same. Yeah, this is right, and this change C4, which is right, and solve it one more time. And say OK for it. So as you can see, give me another solution. So this is going to be my second solution. So I'm going to copy this solution here and Control V here. And I don't want to adjust the keep value only. So this is my second solution and accept that. And if I remembered right, if I type 1 there, it's going to be 0 as well. So 1 is going to be my third solution here. So I got actually 3 solutions here. So like we said, it's going to be 3 solutions for this formula. And in order to, so let me go back to 0 and solve it one more time and say OK. So it will give me the same solution here. So when x equals 1.4586 something, then it's my solution, and save the work here. Okay, so here are our solutions for this equation. And now let's go to the second equation. So here are variables x, y, z, and we will need to type in formulas here. So the formulas we're going to type in equal sign. It's going to be x plus y plus z minus 6, and hit enter. So same thing, we move everything to the left. And the second formula, we put an equal sign here. It's 2 times y. So y, you set the cell, plus 5z times z, and minus 4 there. So we need to plus 4 and hit enter. So it's 2 times x plus 5 times y minus z minus 27. This is my third formula, and save the work. And this is a linear function, so we should have a unique solution for x, y, z. And now let's solve it. So go to solver here, and objective function, I'm going to set the first one. So the first one here, I wanted it to be a 0. And by changing variable cells, so that's 3 cells, you can change the values for x, y, and z. And also the other 2, I'm going to treat them as constraints. So go click here and click add. And the reference cell is going to be the second cell here, and I want it to be 0, and do add. And also the third cell, I want it to be 0, and do OK, because this is my last one. And instead of nonlinear, it's going to be a linear equation. So like we said, this is a linear system. And do a simple linear equation, so linear program. And you could solve it. And when you put in, so you also could put the second formula as your primary equation, and put the first and the third one out as your constraints. That doesn't matter, so you can put each one. So I'm putting the first one and make the second and the third one as my constraints. Now I'm going to solve. Where is the solver? Oh, let's see what's happening here. Oh, couldn't find a solution. So let's say OK here. Okay, then let's try it one more time. So delete all these numbers and solve it one more time, see what's gonna happen. So make constraint variables non-negative should be okay, and solve it one more time, and still couldn't find a solution. Okay, so let's go to our solver one more time, and at this time let's try uncheck the make unconstrained variables non-negative, which means your answers could be negative. Then let's do it one more time, and at this time it found a solution, and let's say okay. So in this case, so z could be a negative number here, so it could be a -1. If your part, they are real problems, so let's say if those things, they are all your time, then you know time can't be negative. Also the number of person, so it can't be negative either. So at that time you could set a constraints with non-negative one. So anyway, so this is a solution. And now let's go to the third tab. So type in the formula here first. So it's going to be equal 2 times x squared, so square it, and plus y squared, so y and square it, and -1. This is the first one. The second one is going to be put a parenthesis 0.5 times x minus 0.5, and put a parenthesis and square it, and plus 2 times parenthesis y minus 0.25 parenthesis and square it, and -1. And this is the formula. Oh, I typed something wrong. Let me find those, see what typo that was. Plus 2c squared -1. What's the difference? Anyway, we'll accept the change first and then see I'm missing a time here. So suppose we have a times here, and this is correct. So I'll put it here and save the work, and we're going to solve it. So like we said, this is a nonlinear problem because it has a square here, so it's a nonlinear problem. So let's go to solver and set the objective function. I'm going to select the first one. So okay, I'm going to select the second one here. So actually they are the same, and make the value as 0. And by changing variables, I'm going to select the top two here. And also I need to add constraints here. So I'm going to add a constraint. So the constraint is going to be the first one because the second one I made as the objective function. And make it to be 0 and say OK. So it's added here. So this is a nonlinear problem. So make sure you check the nonlinear problem and make it a unconstrained. We'll see, and if it doesn't work, we'll come back and let's solve it and find a solution. That's a good thing, and say OK for that. So save the work. So as you can see, the values there are almost 0 because it's a -2 times 10 to -7, so it's a very small number, and times 10 to -8 it's a very small number, and x and y, so these are our solutions. Okay, so if you click this number here, so it's not showing, so this number is technically 0.023456 oh, I'm sorry, 2. Let me see if it's right. 1 2 3 4 5 6 7. Yes, so technically this is this number, so it's super small. Okay, it's showing more things. 1931. So this is a showing this again. So this is technically this number, so we can treat it as 0. If you don't like the tolerance, if you still don't think it's close to 0, then you can, in Excel solver, you could set something else, make the tolerance to be even smaller. Anyway, so this is the solution here. And now let's move to the next tab and work on the heat transfer, the heat balance problem. So I'm going to type in the formulas first. So like we said, move everything to the left. So this is going to be a minus sign, and this is going to be a minus sign as well if you move everything to the left. So the formula, I'm going to put equal. So if you're actually smart, if you look at the equation here, we actually don't need the area because they get canceled out. Okay, we actually don't need the area. And right now we just type them in just to show you how to use it. So it's the area here and the times the top one and the bottom one. So you need to make sure the order of operation. So I put a parenthesis TF minus TI. So TI is what you're looking for. It's going to be this cell. And close the parenthesis, divided by RP, which is this number, plus RI, this number here, and minus H times A times parenthesis TI minus TA parenthesis and minus the sigma here times area times E times parenthesis. I need 2 of them, and it's TI plus 460 and close the parenthesis power to 4 minus parenthesis TA plus 460, close the parenthesis and the power to 4 and close the parenthesis. So this is my formula. And now let's save the work, and we're going to solve this problem. And this objective function is going to be this cell, and I want to make it to be 0. And the changing variable cells is going to be TI, and that's all I have. It's a nonlinear equation apparently because it has the power to 4 here and times something else. So it's a nonlinear one, and it has to be a positive number because we're looking for a temperature. It could be a negative, but it probably won't make sense now. The installation temperature, we don't want to drop to below to 0. So we'll check, make unconstrained variables to be non-negative and solve the problem. And we got a solution and accept that. So formula is close to 0 and the temperature is 81.25 degree F. So this is the solution. And now let's go to the last one. So the last one, so this is a department store staffing problem, and this is my objective function in the subject tool. So we're going to type in all the formulas here. And objective function, so equal, and here are all my variables, Monday until Sunday one. So I'm going to equal and use sum instead of type everything in. So select all those numbers and close the parentheses. That's my objective function. And I'm going to put all the constraints in. So equal, it's Monday plus Thursday until Sunday. So I'm going to use sum again. So sum from Thursday until Sunday, and close the parentheses. In the next one, Tuesday, it's Monday plus Tuesday plus Friday, Saturday, Sunday. Okay, Friday plus Saturday plus Sunday. And Wednesday one is Monday, Tuesday, Wednesday. So it's a Monday, Tuesday, and Wednesday. Skip 2 days, and Saturday and Sunday. And the Thursday ones, it's equals to Monday, Tuesday, Wednesday, Thursday. You can skip 2 days and have a Sunday here. Oh, put one more plus there. It's right. And Friday equals to Monday, Tuesday, Wednesday, Thursday, and Friday. Oh, yes, and Saturday one is Tuesday. Oh, I'm going to use a sum. So sum here, and from Tuesday until Saturday, and inner. And the last day, Sunday, is going to be a sum. Then from Wednesday until Sunday, and inner. So I only put the left side. The right side, I haven't put any numbers yet. So you could put it there. So move everything to the left. Minus 12, minus 18, minus 20, and put it here. And you could also put it in somewhere else. So I'm going to show you something else here. So save the work and go to solver here. And the objective function is going to be the first one. And I want to minimize that. Okay, I want to minimize all the staffing, the number of staffs there. And by changing variables, so those are my variables. So select all of them. And add constraints. So constraint is going to be the first one. The Monday's one needs to be bigger than 12. So greater or equal than 12. And add there. And do Tuesday one needs to be greater or equal than 18. And add that. And Wednesday one greater or equal to 20, and add that. And Thursday greater or equal 28, and add that. And Friday greater or equal to 32, and add that. Saturday greater or equal to 40, add that. And Sunday one greater or equal to 40, and this is the last one, so we do OK. So all your constraints are here, so make sure everything is right. That looks right to me. And all those problems, this is a linear one because it's just x, a whole bunch of x there, no exponentials, no square roots, and no logs there. So I'm going to change it as a linear problem. And also I probably don't want to have a negative numbers because the number of staff, it can be a negative number. So leave this check, and linear, simplex linear programming, and solve it. Oh, I got a solution, and say OK for that. And in this case, so I need to hire at least 42 people there. And so nobody starts working on Monday, and 2 people start to work on Tuesday. 24 people start to work on Wednesday. Nobody start to work on Thursday. 14 people start to work on Friday, and 2 people start working on Sunday. And it turns out to be on Monday I'm going to have 16 people on the shift, even though I only need 12 people. And Tuesday I have 18, and Wednesday I have 28. Thursday I have 28. Friday will have a 40, and Saturday and Sunday I have about 40 people there as well. And this is the minimum number of staff that I need to hire in order to satisfy the schedule here. And this is all we have for Excel Solver. And thanks for watching. We'll see you next time. Bye.